Let's say we want to find the average value of a series of numbers, and let's call these numbers y1, y2, y3, and we can say they go all the way to yn. This is pretty straightforward, and most people have already seen how to do this before. All you do is you simply add up all these values of y, so y1 plus y2, all the way to yn, and you divide by the number of elements that there are, in this case, and that gets you the average value. Pretty straightforward. But now let's say we are tasked with finding the average value of a function, f of x. And let's say the function looks something like this. It can really look like anything, any function. This technique will work. And let's say we want to find the average value between x equals a and x equals b. So that's going to be between here and here. One way to do it is by taking the value of the function at specific points and averaging these values. It's not a perfect answer, but it's an approximation. We can approximate the function by taking a finite number of values between a and b and averaging them. In this case, the average value of the function is simply going to be f of x1, where let's say this is x1, this is x2, and let's say we have n different points. So the average value of the function is going to be f of x1 plus f of x2, and we sum this all the way to f of xn, and then we divide by n. It's the same procedure as before when we found the average value of y. Another way to represent this is like this. F average is simply f of x1 plus f of x2 plus, just as before, all the way to f of xn. Now, however, let's put this in terms of delta x. And delta x, we're going to call delta x the width between these adjacent points. So delta x is just going to be b minus a divided by n. It's going to be this whole distance divided by the number of points, and that's going to get us the average distance, or the exact distance between each point. So in that case, if delta x equals b minus a over n, then this means that n is simply going to be b minus a over delta x. Okay, so let's go ahead and we'll plug that in inside the equation that we had before. So this is now going to be divided by b minus a over delta x. So simplifying this, we know that dividing is the same as multiplying by the reciprocal. So this means that the average value of the function is f of x1 plus f of x2 plus all the way to f of xn, and we have this times delta x, and then divided by b minus a. This is a handy formula for finding an approximation of the average value of the function. But let's say we don't want an approximation. Let's say we want the exact value of the exact average value of the function between a and b. What do? Well, this is where calculus comes in. This is one of the very important applications of calculus that we can use. So let's say we want to find the exact value. What we can do is we can take the limit as n goes to infinity. In other words, instead of only finding the value of the function at n points, we're going to find the value of the function at infinitely many points. So we're going to take the limit as n goes to infinity. So now the average value of the function, and this is the exact value. write this in some absurdly pretty ink. The exact value of the average of the function is simply the limit as n goes to infinity of, I'm just writing this in a slightly different way. We're going to move the 1 over b minus a out front, and this is f of x1 plus f of x2 summed all the way to f of xn, and then times delta x. Well, you probably remember from integral calculus that this can be changed into an integral. Once we take the limit as n goes to infinity of a sum such as this, where delta x is the distance between adjacent x values, what this becomes is the integral of 1 over b minus a, and this is the integral from a to b because we're dealing with the average value of the function between a and b of 1 over b minus a times f of x dx. Because remember, as n goes to infinity, delta x has to go to 0, because now we are calculating the value of the function at infinitely many points, so the distance between each of those points, which is delta x, has to go to 0. And once delta x goes to 0, we express this as dx, the differential of x, an infinitesimal difference in x values. And 1 over b minus a, this is simply a constant here, because these are the values that we're finding the average of the function in between. So we can pull this out in front of the integral, and we now have the average value of this function is 1 over b minus a times the integral from a to b of f of x dx. And this is the exact answer to the problem we were looking for. This is the exact way of finding the average value of a function. So now let's just do a really quick example, and let's say we want to find the average value of x cubed. So let's say f of x equals x cubed, and let's say we want to find its average value between a equals 1 and a equals 3. B equals 3. Okay, well, the average value, just plugging these in, is going to be 1 over 3 minus 1 times the integral from 1 to 3 of f of x, which is x cubed, dx. Okay, so this is 1 over 2 times, and the integral of x cubed dx is just 1/4 x to the 4th, and this is evaluated on the interval from 1 to 3. So simplifying these fractions, 1/2 times 1/4 is 1/8, and we have x to the 4th over the interval from 1 to 3, so this is going to be 3 to the 4th minus 1 to the 4th. Make that a little nicer here. And that is going to be 1/8 times 3 to the 4th is 243, and 1 to the 4th is 1. So this is just going to be 242 over 8. So the average value of the function x cubed between the values of 1 and 3 is simply 242 over 8, and this can be simplified further if you desire.